Hi everyone. In this video, I'm going to explain about the read-only memory, which is a programmable logic device. Okay, this is what I have started in the previous video. Programmable logic device is a special device that it is an IC which is used for general purpose. Okay, it avoids the drawbacks of standard ICs, what we have seen here, and as well as as well as the ASICs. Okay, now coming to the ROM. ROM is nothing but definition of ROM is read-only memory. Read-only memory ROM. Okay, now let us look into the ROM in detail. Read-only memory. Read-only memory ROM. So by seeing the name, we can say that it's just a memory which is used to store the data. Whatever the data that the memory has, that we can read it, and again, again we cannot store. That is the main problem of this ROM. Okay, so a ROM is essentially a memory device in which permanent binary information is stored. In which permanent binary information is stored. Okay, this is what the ROM is nothing but a location which is used to store the data permanently. The binary information must be specified by the designer and is then embedded into the unit to form the required interconnection pattern. See, once the pattern is established, it stays within the unit when the power is turned off and on again. Okay, so what is the main purpose of ROM is, even if the data is stored inside the memory, if the power is gone, the data will not erase. The data stays back. The data, the data inside the ROM, stays back even the power is switched off. Even the power is switched off. Okay, that is the main purpose of ROM which can be programmed. Okay, this particular ROM alone we cannot reprogram, but the ROM which is programmed is known as programmable read-only memory. A ROM which can be programmed, which can be programmed is called a PROM, nothing but programmable read-only memory. Programmable read-only memory. The process of entering the process of entering information into a ROM, entering information in a ROM is known as programming. So programming is nothing but, we can understand, it is writing of data. Programming is nothing but writing of data. Suppose this is the ROM, and we are writing some data. Okay, this particular writing of data is nothing but your programming. Okay, the way the data is entered into the ROM. Okay, so ROMs are used to store the information which is fixed type, such as tables for various functions, fixed data and instructions. Okay, so ROM can be, the main purpose of ROMs can be used for designing combinational logic circuits. Combinational logic circuits. Okay, in the previous videos, I have given the explanation of decoders and multiplexers, how they can be used to design a combinational logic circuit. In the similar way, ROM is a device which is used to design a combinational logic circuit. Whatever the logic function you are going to implement, that can be implemented with this read-only memory or programmable read-only memory. Okay, depending on the type of the ROMs used, depending on type of ROM used, a user can design a user can design and modify the circuits easily. The circuits easily. Okay. So the advantage of ROM as a PLD, because ROM is a part of PLD. So the advantages of using a ROM as PLD, as a programmable logic device. ROM is, we are using ROM as a programmable device. That means we are erasing the data and again reprogramming the data. Or, so what are the advantages we have when we are using a ROM as a PLD? So ease of design, since no simplification or minimization of logic function is required. Ease of design, since no simplification or minimization, no simplification or minimization of logic function is required. And designs can be changed as it is programmed. Designs can be changed modified rapidly. Designs can be changed and it can be modified rapidly. It is usually faster than medium scale integration technology and small scale integration technologies. And the fourth one, cost is also low. Cost is also reduced. Along with advantages, we also have some disadvantages like non-utilization of complete circuit. The main disadvantage of this particular programmable read-only memories are disadvantages of ROM or first one, non-utilization. Non-utilization. Okay, you can understand what do you mean by non-utilization of the ROM. Entire terminals is nothing but I will tell you when we go into the circuit design. Non-utilization of complete circuit. Complete circuit. The meaning of this one is we are having an array. Okay, the output consisting of a lot of arrays. Suppose we are having all these horizontal lines and all these vertical lines, and the outputs are connected to something like OR gates. Whichever data is connected, whichever line is used, that particular line is connected with a fuse or a transistor, whatever it is. Okay, like this, like this. Okay, whatever the remaining lines and remaining a lot of data is wasted. Okay, that means that circuits are made, but we are not completely using it. So that's why non-utilization of complete circuit, increased power requirement. So because of that, what happens? Unnecessarily we are using the power requirement. So increased power requirement because of this first point only. That is the second point is the reason for the first point. Second point is having the reason of the first point. So enormous increase in the size with increase in the number of input variables, making it impractical. Okay, size is also high. Size is high. Okay, this is what the disadvantage and advantages of the ROM. So generally, what do you mean by the size of the ROM? ROM is having a size. This till now we have seen what do you mean by ROM and how it is going to be programmed and what are the advantages and disadvantages. So now coming to the size of the ROM, ROM has a size like 2 power k by n. 2 power k 2 power k by n. This is the size of the ROM. ROM size is somewhat different. So with the inputs, k number of inputs, k inputs and n number of outputs, n number of outputs. Okay, so 2 power k by n, it is the size of the ROM, and k here denoting the input numbers, and n denotes the outputs. N number of outputs are there, k number of inputs are there. Okay, let us consider k is equal to 3 and n is equal to 8. Then something like k is equal to 3 means suppose k is equal to 5. Example, k is equal to 5 and n is equal to some 4. What do you mean by this? What is the size of the ROM? So ROM size is 2 power 5 is 32 and we are having 4 outputs. So 32 by 4. Where 32 by 4 here the size actually denotes the array. Size actually what it means? Size denotes array. Size denotes the array. See, for example, consider 32 by 8 ROM. Consider 32 by 8 ROM. That means 2 power 5. 32 means 2 power 5. What is the value of k? K is equal to 5. So 2 power 5 by 8 means k is equal to 5, n is equal to 8. The logic diagram of this particular 32 by 8 is we are having 5 inputs. So those inputs are I0, I1, I2, I3, I4. So 0 to 4, total 5. And its size is, what is the size? 2 power 5, nothing but 32 by 8. 8 denotes the outputs. 8 actually denotes the outputs. So 32 by 8, 32 by 8. Whereas 32 is there here. 0, 1, 2, and so on. 28, 29, 30, 31. So totally we will be having 32 horizontal lines. 32 horizontal lines. Okay, actually we should not show 8 here. See, the first block in the ROM is a decoder. 5 to 32 decoder. 5 to 32, 2 power n by 2 power n. Decoder size is n by 2 power n. We know it very well. So n by 2 power n. What is n size here? Input 5. So 5 by 2 power 5, nothing but 32. So 5 by 32. This is the first part of the ROM is decoder. Okay, it is a decoder which is having 5 inputs and total 32 outputs. Out of these 32 outputs, we are having only 4, sorry, not 4, 8 outputs. 8 outputs are represented as 8 OR gates. 1, 2, 3, 4, and so on. 8 targets. Okay, 1 2 3 4 and so on, 8 targets. These are the outputs. So y1, y2, y3, y4 and so on. Y, otherwise you can start it with the y0. So y0, y1, y2, y3 and so on, y7. So total 8 outputs are there. Now we have to draw vertical line. This is the connection that gives the output of a decoder to the output, overall output, y1, y2, y3, like that. Okay. Okay, this is the line. Now when we have suppose, for example, if I say 2 is there, 7 is there, 28 is there, 9 is there, then what we have to do? Why not? Let us consider y0 is a set of, consider y0 is a set of summation of m of something like 2 5 7 32 28, like that. And similarly y1 is a set of min terms of 1 2 7 10 11, like that we will be having. And similarly y2 and so on, we will be having up to y7, which is summation of min terms of a different values. Okay, which are the values that represent in this particular y0? Those are taken as a group. Suppose if we are having 2 5 7, so 2 must be connected, fifth line which is the here must be connected, seventh line which is here must be connected, and 28 which is here must be connected. These cross marks representing the fuse. These are fuses are used to connect horizontal and vertical line. Fuse purpose is to connect horizontal and vertical line. Okay, if fuse is not there, see, if we suppose consider this location, in this location we don't have any cross or dot, that means it is not having any connection between this horizontal and vertical line. Okay, so wherever the cross mark is there, there it is showing that it is a connection. Okay, after this purpose you can simply remove this connection, so it is a fuse. It is actually a fuse, like this, in S shape. It is a fuse that connects these two. Okay, whenever it is required, the fuse is connected. Whenever it is not required, fuse is simply open circuited. Okay, that's why it is programmable. That's why it is programmable. Programmable is nothing but we can write the data and we can delete the data, and again we can rewrite the data, like that. Okay, similarly wherever we are having the connections, that particular vertical and horizontal lines must be connected like this. Okay, if you see this, suppose if you see this horizontal and vertical line, all the gates are having these horizontal and vertical lines at the inputs of them, at the inputs, but whichever is required, that will be connected. So that's why this particular point is the major problem, non-utilization of the complete circuit. Here the complete circuit is not utilized. Complete circuit is not utilized, only part of the circuit depending upon the expressions we are using. Okay, this is about the ROM. Okay, if you understand the size of the ROM, see this is the size 5. See, these are the size 8. So 5 inputs, 8 outputs. 5 inputs, 8 outputs. But the internal array is, what is the size of the array? 32 lines, 32 horizontal lines and 8 vertical lines. The array size is 32 by 8. 32 by 8. That means the data can be stored in 32 horizontal lines, and as well as we can retrieve that data in 8 vertical lines. We can retrieve the data in 8 vertical lines. This is the size of the ROM. Hope you understand what do you mean by 32 by 8. 32 by 8 is nothing but size of the ROM, which is used to store the data. Okay, in which 5 shows the inputs and 8 shows the output. Okay, this is what the ROM